This is Lesson 5, Managing Oracle Backups. This is the 5th lesson in this course. In this lesson, you'll learn about the overall structure of the Oracle database and the important considerations for backup administrators. You'll learn how to configure NetBackup to backup and restore Oracle databases. You'll learn how to monitor and maintain Oracle database backups. And you'll learn about Oracle disaster recovery considerations. This is the introduction to the Oracle database topic. This slide shows a high-level overview of the Oracle database architecture with a focus on the information that the backup administrator really needs to know. You'll see that each database client, i.e. a database server, can host one or more Oracle instances. An Oracle instance is a set of shared memory called the System Global Area and processes that provide access to the database. Now, the actual database files on disk is what we're most concerned about as backup administrators. So we see that there are data files, which contain the actual data in the tables in the database. There are the redo logs. All transactions going to the Oracle database hit the redo logs first, and archiving copies of those redo logs allow us to provide up to the point of failure protection for the database. Then there are other files, such as the database control file, which contain critical metadata about the database or database instance. We'll describe in a little more detail the function of these files in subsequent slides. A database is a combination of logical and physical structures. The database itself is a logical structure which contains one or more table spaces. A table space is a logical structure which is stored in one or more data files. The data files are the actual physical structures that contain the user data and the Oracle Data Dictionary. The redo logs record all changes made to the database. All incoming transactions hit the redo log before they're applied to the actual data files. And this is an important mechanism for database consistency and recovery. If there's a problem with a transaction, then the Oracle DBA can roll back the database using the redo logs to a consistent state. And this is how a database is able to be healed without always needing a restore, for minor problems. The redo logs are written in a circular pattern, and they're organized into groups, and so when all of the available redo logs have been filled up, we begin overwriting back at the first group again. The online redo logs are in current active use by the database. Now, optionally, we can have the database archive copies of these redo logs before they are overwritten, and then a backup application like NetBackup can come along and protect them, something that's usually done at pretty frequent intervals so they don't start to hog up a lot of disk space. Remember, every transaction goes into the redo log. But there's a lot of value in protecting archive redo logs because it makes recovery up to the point of failure possible, and it allows for additional flexibility in the types of backups that we can do, as we'll explore in this lesson. Here's some additional information about the contents of some of the Oracle database files. The database control file is a critical piece of metadata that describes the structure of the database and is always open when the database is in use. In addition, the Oracle Recovery Manager by default will be recording backup activity to the database control file. The parameter file contains database startup settings, such as memory settings, and there are two types of parameter files. Modern versions of Oracle use an SP file, which is a binary file. Older versions use a P file, which is a text file. There's a subtle difference there in that full backups of the database automatically protect the newer SP files and do not automatically protect the older P file type of parameter files. And it's possible that a password file may also exist if you're using Oracle authentication to manage permissions for who can access the database. This slide shows different modes of Oracle operation. In the shutdown mode, the database instance is not started, all files are closed. Basically, Oracle's completely offline. This is the state I would have it in if I was taking a completely cold point-in-time backup. The no mount state means that the database instance has started, however no files are opened. So if I needed to do a control file recovery of an Oracle database, I'd be in this mode. Move up a level to the mount mode. That means the instance is started, the control file is open, and so the contents, the structure of the database is visible. And then the open mode is where the database is fully operational. The instance is started and all files are open. There are different types of backups of Oracle databases that can be performed. In this slide here, we're looking at physical backups versus logical backups. A physical backup is a copy of the physical files that make up the database, the data files, the table spaces, or the complete database. And this can be performed either offline or online. Now, by comparison, a logical backup is a binary copy of the database that does not record its physical structure. A logical backup is really what Oracle would call an export, and it's primarily used for the long-term retention of data in a self-describing XML format. This lesson, we're going to focus on physical backups of Oracle databases. Physical backups of Oracle databases can be one of two types, either offline or online. Cold or hot would be different terms to describe it. A cold or offline backup is performed when the database is offline in the closed state. And so this means that the database could be running in either archive log or no archive log mode. Doesn't really matter because it's shut down. And this allows for a consistent backup of the database, but it limits our recovery options. The only thing we can really do here is a point-in-time recovery, where we put the entire database back the same way it was at the time of the last backup. Now, by comparison, the hot online backups are performed when the database is online. So I didn't have to take it offline to back it up, which is a big deal right there. It requires that the database be running in archive log mode, and we're periodically backing up these archived redo logs. And that means that we can recover the database right up to the point of failure by recovering and restoring the archived redo logs. And this does mean that the recovery is sort of two steps. There's the restore step where we put the actual data back, and then there's the recovery step where we roll forward to the point of failure. One advantage I suppose an offline backup has is there's no real recovery step. There's just a restore. There's just put it back the way it was at the time of the last backup. Depending on the mode that the database is running in, archive log versus no archive log, we have different options for the type of backup that can be performed. A full database backup backs up all data and the control files, and it can be performed in either mode. More granular backups, such as a tablespace backup, where we back up just the data files that constitute a particular tablespace, or a data file backup, where we're so granular we back up just a single data file. Those require that the database is running in archive log mode. And so that's another advantage to running an archive log mode. In addition to recovery right up to the point of failure, you get more flexibility in terms of your options for protecting the database. Other types of backups, a control file backup backs up the database control file only. Redo log backup backs up the archived redo log files only. We never back up the online redo logs, because applying an online redo log may contain incomplete transactions that could cause corruption of the database. So it's the archived redo logs only that we're interested in protecting. As we mentioned, it might be very frequent backups of these redo logs that we were doing because they can grow quite large over time, since all incoming transactions hit the redo logs before being applied to the data files. The Oracle Recovery Manager, RMAN, is a standard utility included with Oracle that manages all backup and recovery operations. When we use the NetBackup for Oracle agent, we'll be working with RMAN to accomplish data protection and recovery. RMAN has an API with which the NetBackup for Oracle agent integrates, and NetBackup interacts with RMAN to specify backup and recovery operations. RMAN is a fairly robust database protection utility which stores the collection of metadata about the target database and what objects have been protected in a repository. Now, this repository is always kept in a control file of the target database, and optionally it could be kept in a recovery catalog. This recovery catalog could be kept in another database. In large Oracle installations, it's common to have a dedicated database with a centralized RMAN repository to make the management of this metadata easier and also to allow for some protection, to periodically back up and add some resiliency to it. Now, RMAN is keeping track of database backups that have been performed and the contents of the backup pieces that are being sent to NetBackup. NetBackup doesn't really know the exact contents of a backup piece that's sent by Oracle, unlike a file system backup where NetBackup is maintaining these detailed records of each individual file in a backup image. NetBackup is really just tracking, hey, Oracle gave me this stuff and it's important that I hold on to it. But it's the RMAN repository which really tracks the exact contents of those backup pieces. So there's 2 points of monitoring backups. And so it is possible and necessary to periodically cross-check the NetBackup image catalog with the RMAN repository to make sure they're in sync with each other, which we'll discuss a little later in this lesson. An RMAN backup set is a collection of one or more backup pieces. Backup pieces contain components of the database that are being protected: data files, control files, and archive logs. Different types of database objects will always be part of different pieces within the backup set. And so a backup set will contain all of the data from a full or incremental backup, and it will be in an RMAN proprietary format. It'll be sent to NetBackup, where it may be written to tape or to disk, and this is all controlled by RMAN. The RMAN backup command is used to generate backup sets. Data file backup sets can be full or incremental. A full backup involves one or more data files and contains all of that data file's data blocks. Incremental backups copy only changed data blocks. These types of backups can be performed either hot or cold and can be performed in archive log or no archive log mode. Incremental backups can be either differential or cumulative, and those terms mean the same in Oracle as they do in regular NetBackup policies. This slide highlights what is backed up in different types of Oracle backups. Full or incremental backups back up the database, the table spaces, and the data files. Archived redo logs are backed up by full backups only. Control file backups, also always a full backup. And SP files, the newer type of parameter file, are captured in full backups only. Note that RMAN backups do not back up the older P file type parameter files, or password files, or any other operating system files that are critical on that server, nor do they attempt to back up online redo logs. So if any of those components are present and critical, they should be protected by standard or Windows policies. P files, password files, and operating system files would be protected by standard or Windows policies. Online redo logs we would never attempt to protect because, again, they are no use to us in recovery since applying them can corrupt the data. This slide shows the Oracle Server processes and the Media Manager library and how they interact with NetBackup. Essentially, the Oracle RMAN Recovery Manager sees NetBackup as its media manager. Oracle's RMAN has the ability to natively do backups to disk, or it has the ability to send data through an API to a third-party media manager. And those are the only real 2 options that RMAN has. The disk backups it can handle on its own, anything else it's going through a third-party product. And NetBackup is that third-party product. So NetBackup is providing this Media Manager library, which connects to the Oracle's API so that RMAN can send data to an alias, and any data sent to that alias goes to NetBackup. Now, Oracle describes this as a third-party media manager because, it's thinking that it's probably writing it to tape. Of course, these Oracle policies could be going to any supported NetBackup destination. Could be tape, could be disk, could be deduplicated disk, it could be the cloud backups. What NetBackup does with the data afterwards, Oracle really has no say in. Or Oracle is just going to send data to this alias, and then it's going to get handed off to NetBackup. Oracle is going to be tracking the contents of these backup sets in RMAN's repository in the Recovery Catalog database. NetBackup is also going to be tracking that these backups have occurred in the image catalog. This is the Configuring NetBackup to Backup and Recover Oracle Databases topic. This slide shows a high-level overview of configuring NetBackup for Oracle backups. The first thing, and this is for Unix and Linux systems only, is to link NetBackup and Oracle. We run the Oracle link script, and this associates Oracle's SBT tape alias with NetBackup's Media Manager library. We're making a connection between NetBackup and RMAN. Now, this happens in Windows as well, but in Windows it happens automatically, whereas in Unix or Linux it's a specific step to run this script. Next, if we want to do hot backups up to the point of failure, then we ensure Oracle databases are running in archive log mode. We configure NetBackup for Oracle policies, and then we modify NetBackup for Oracle database backup scripts or templates if we'll be using the legacy method, or if we're using intelligent policies, that step of modifying scripts or templates is not necessary. In the examples in this lesson, we'll be using Oracle Intelligent Policies, so the configuration of specific scripts will not be necessary. As we discussed in the previous lesson, there are different strategies that can be used for protecting Oracle databases. The coolest way to do it, and the way that we'll be discussing in this lesson, is using the NetBackup for Oracle Agent, which Veritas strongly recommends. Now, there are two types of Oracle policies since NetBackup 7.6. The legacy Oracle policies are the traditional method for protecting it, where the backup policy executes pre-created scripts to invoke RMAN activity. And this works with any type of Oracle environment, including Oracle RAC. And with legacy Oracle policies, the master server is not really aware of which specific databases are being protected. It's just, again, backing up this data that RMAN is sending to it. Now, starting in 7.6, we introduced Oracle Intelligent Policies, which means that specific Oracle instances are registered with the master server. So the master server is aware of the Oracle instances and the Oracle databases that it's protecting. And the intelligent policy will dynamically generate scripts to back up these known database instances. And that eliminates the necessity to write our own scripts to protect Oracle databases. Now, limitation here, these are not used for interactive RMAN backup sessions, and it does not support Oracle RAC, but it is a much simpler method for protecting Oracle, in particular because the backup administrator does not need a detailed knowledge of how RMAN works to accomplish it, nor do they have to take up a lot of the DBA's time creating these scripts, as would be required with the legacy method. To use Oracle Intelligent Policies, the Oracle instances must be known and registered with the master server. Known instances have information stored about them in the NetBackup database, and registration adds credentials used by NetBackup to access the instance. Now, the two methods that are used to make an instance known are automatic discovery or manually added. Instance discovery for Oracle Intelligent Policies is automatically performed on NetBackup clients, when the NetBackup client software starts, and every 4 hours thereafter, the excellently named NBDisco process will conduct instance discovery and record basic information about database instances. The exact method it goes about doing this is platform specific. In Unix or Linux, we're looking at the ORAtab file. In Windows, it's scanning the registry. Now, this instance discovery can also be initiated manually from the NetBackup administration console. The Oracle instances that are known to a master server can be viewed from the NetBackup administration console by going to Applications and then Oracle. We can view database instances that have been automatically discovered. Instance discovery can also be invoked manually. From Actions, I select Discover Instances, and all clients that have previously discovered instances will be rescanned by NBDisco to collect updated information. It may take about 5 minutes or so for this information to be displayed in the console. Manually adding an instance is also possible. There may be cases where an Oracle discovery doesn't happen automatically. For example, if an Oracle server is configured with 2 master servers in its server list, only the master that appears first will be sent discovery information by NBDisco. For the second master server, I would need to manually enter the instance information. So I'm going here to Actions, New, and then New Instance, giving information about the database instance, and possibly adding registration information, the credentials that I need to access the database. This can also be done from NB-ORA-ATOM from the database server, and that possibly will be an important consideration if the credentials for the database are secure, and it's desirable to have only the DBAs know the credentials to the database and not share them with the backup team. The DBAs can add this information themselves as long as they're granted permission to do so by the backup admin. Before an Oracle instance that's been discovered can be protected by an intelligent policy, login credentials must be assigned to the instance, and this is a process known as registration. Now, these credentials can be assigned to individual instances, or you can use an instance group. With an instant group, the same credentials assigned to the group are automatically used for all instances added to that group. If the group credentials change, the new credentials are used for all associated instances. And this supports auto-registration for automatically discovered instances. If an auto-registration instance group has been assigned, then any newly discovered instance will be automatically assigned to that group, and NetBackup will try to use the credentials of the group to log on to those instances. And again, this registration can take place from the NetBackup administration console or from an Oracle client itself using the NB-ORA-ATOM utility. To create an instance group, I select Actions, New, and New Instance Group. I give the instance group a name, and then there's 4 different kinds of credentials that can be specified here. I must specify at least one OS credential, Windows or Unix. I can specify both. There'll be mixed platforms within the instance group. And then I can specify either OS or Oracle authentication. And if I want NetBackup to create RMAN sessions that use a particular recovery catalog database instead of the database's control file for the RMAN repository, then I'll want to provide RMAN credentials as well. You'll notice in the example here that there's a validate button down at the bottom that's grayed out, and that's because initially when the instance group is created, it's empty. Once there are instances that are associated with this group, then I can go back and do validation and make sure that the credentials check. I go to Actions and then Register to register an instance, and in the dialog box I either assign it to an existing instance group, in which case it'll use the credentials associated with that group, or I assign it a specific set of credentials. NetBackup will validate the credentials against the instance by attempting to use the credentials to access it, and if the validation succeeds, the instance will be registered. If the validation fails, then an option to save the changes will be presented. And this is another example of a task that can be performed using the admin console on the NetBackup side, or it can be performed by the DBAs using the nb or atom command from the database server itself. Here's an example of credential validation failure, where I get information that the validation has failed and some details of the error. It might be that I provided the wrong credentials, but it might also be something else. Maybe the instance is not running or the database server is not accessible. In either case, I'll be provided with a description, and then I'll have the option to go ahead and save the credentials anyway, even though we didn't pass validation, or I can click No and change the credentials. When I create an Oracle Intelligent Policy, I'm going to specify Oracle as the policy type on the Attributes tab. I'm also going to specify the storage destination on the Attribute tab, and then I'm going to add schedules. The intelligent policy is automatically going to generate the proper RMAN syntax to protect the data based on the schedule type. A full backup is equivalent to an Oracle incremental level 0, whereas differentials or cumulatives are incremental level 1s. Archived redo logs are a separate schedule type to protect the archive logs. Then there'll be an instance tab, which identifies the instances or instance groups that are being protected, and a backup selections tab, which identifies the objects in an instance which are being protected, either whole databases or parts of databases. The final tab, the Oracle tab, has Oracle-specific attributes that can be adjusted. Here's a look at the Attribute tab for my Oracle policy. You see that as soon as I selected Oracle as the policy type, there are tabs here such as Instances and Oracle, which only appear in Oracle Intelligent Policies. Here's an example of adding schedules to my Intelligent Policy, and I'm using schedule types that are closer to what I use for regular file system backups, fulls, differentials, and cumulatives. The only one that I wouldn't see here in a regular file system backup is the archive redo log backup. So again, that makes it easier and friendlier to do policy configuration. I'm also specifying the retention level in the schedule, as I would do for any backup. Note in this example that they have selected an infinite retention level, level 9, and this means that the backup images will persist theoretically in the image catalog forever. But what's actually going to happen here is the retention is probably being controlled by the RMAN repository. And so RMAN is the definitive source for the retention. And when cross-checks are performed, backup sets that are no longer present in the RMAN repository will be removed from the NetBackup image catalog as well. Since either RMAN or NetBackup can be handling retention, it's a choice that we're really going to make as to who is the authoritative source for retention. By setting things up in NetBackup this way, what we're really saying is that RMAN is managing retention. As with most backup schedules, we'll specify either a calendar or frequency-based backups. You'll notice that for archived redo log type backups, we can be a little bit more granular here than normal, where we can have a frequency measured in minutes instead of hours or days or weeks, and that's something that might be desirable. Again, archived redo log backups are sometimes taken at 15-minute intervals because they can grow quite large. We want to protect these as often as possible so that they can then be deleted from the database server. Also, of course, recovery point is an important thing to consider. The more often I'm protecting these archive redo logs, the better my recovery point is. The Instances tab allows me to select whether I'm going to be protecting instances or instance groups. Let's say, for example, I select instances, as I have in this example here. I'm then presented with an interface where I can browse the discovered Oracle instances and select which ones will be protected by this policy. Note the third option up there at the top to select clients for use with scripts or templates. Selecting that option would essentially transform the intelligent policy into a legacy policy, where I would go back to the traditional method of protection where I specify particular database servers and NetBackup is not aware of which databases are present on those servers. NetBackup is just going to execute a bunch of scripts when the policy runs in a legacy policy. The Backup Selections tab allows me to specify exactly what's going to be protected when this policy runs. Do I want to back up the whole database? Do I want to do a partial database backup of just certain table spaces or certain data files? Do I want to back up the flash recovery area? As with file system backups, intelligent policies don't require that every object that is listed in a backup selection be found on every instance protected by the policy. If each protected instance has at least one item listed in a backup selections list, the backup will exit successfully. If a particular instance has none of the selected items, then the job will fail with a status 5400. And that's sort of the Oracle Intelligent Policy equivalent of the status code 71 that we'd get in a similar situation with a standard or Windows policy. The Oracle tab of an intelligent policy is where Oracle-specific options can be set, and there's a lot of different options that can be configured from here. The number of parallel streams, I/O limits, naming conventions. There's different options here which will correspond to specific syntax that will be placed in the RMAN scripts that the intelligent policy is going to generate for us. This is the monitoring and maintaining Oracle database backups topic. This slide shows an example of the kind of jobs we'll see in the activity monitor when using Oracle Intelligent Policies. So in this example, job number 87 is the discovery job. A discovery job goes through and invokes child jobs called BPHDB jobs for each instance that's being protected. So for each instance, there's a BPHDB job, be job number 88 in this example. There's just a single instance. And the BPHDB job generates the RMAN syntax to protect the data. It invokes RMAN, and it displays responses from RMAN. And then the children of those BPHDB jobs, in this example 88, 90, and 91, these are the actual backup jobs that are actually protecting data. And each backup job, as usual, generates a separate entry in the NetBackup image catalog. Each backup job contains one or more pieces of the database, one or more backup pieces that have been sent by RMAN. This looks like it's a full backup of the database, and so the data files, the control file, and the archived redo logs are different backup pieces that are sent on different backup jobs. The exact number of backup jobs can vary based upon the settings in the Oracle tab of the OIP. Here's an example of what we'll see in the BPHDB job details. So we see the actual RMAN syntax being executed here. The allocate channel RMAN command connects Oracle to NetBackup. You can use multiple channels when you protect Oracle, which would be essentially the equivalent of using multiple data streams in another type of backup policy. The send command configures the channel and its variables, and then the backup command actually sends the data through the channel to NetBackup. Note in the output from RMAN session that channel 0 is sending data to SBT tape. That SBT tape is RMAN's alias for third-party media manager. In other words, NetBackup. Any data that RMAN sends to the SBT tape alias goes through that link to NetBackup. With intelligent policies, when backups are initiated, NetBackup passes the variables listed on this table to the script generator and are used to generate the appropriate RMAN syntax to direct the backup to the proper destination. Legacy Oracle policies also use this information, with the exception of the last entry here in the slide, the use required master. That's something that's only really associated with intelligent policies, and it only comes into play if you have an Oracle server that has multiple master servers protecting it. You use this setting to send the backup data to the master server executing the policy, because otherwise the client's behavior would be to send its data to its default master server. Now, as we've discussed previously in this lesson, when you do NetBackup for Oracle backups, you've basically got two catalogs keeping information about the backups. You've got the RMAN catalog, which has got the information about the contents of the backup pieces, and you've got the NetBackup catalog, which is tracking where these backup pieces are stored. Both of this is critical information for recovery, but it means, because we have information being tracked in two places, that there's potential for this information to get out of sync with each other. If the NetBackup administrator was to expire a backup image associated with Oracle, you would have an entry in RMAN with no corresponding entry in NetBackup. Similarly, a DBA could remove an RMAN entry from the repository, in which case you would have an entry in NetBackup with no corresponding entry in RMAN. So ideally, in terms of sane management, the retention of these backups should be managed by one or the other catalog, and then the other catalog should have long-term or infinite retention. By default, Oracle will keep backup information forever unless it's instructed to do otherwise. And we're going to want to regularly perform cross-checking to make sure these catalogs are kept in sync with each other. These cross-checks can be run manually as a script, or they can be run on a schedule. They can even be kicked off by legacy Oracle policies. The cross-checks cannot be part of an intelligent policy. They have to be done manually or by a legacy policy. And there's a sample syntax over here, a pretty simple set of commands to cross-check the backup and reconcile the two catalogs. In this lesson, we discussed the most common Oracle configurations that can be protected by NetBackup. There are other types of Oracle configurations that NetBackup supports that are described in the admin guide and in more detail in the NetBackup for Oracle course, which is a separate 3-day training course. It's available from Veritas. Just to give you some examples here, real application clusters, or Oracle RAC, where you have Oracle instances with multiple servers having write access to the instance. That's something that's supported with legacy policies, but not with intelligent policies. There's integration possible with Snapshot Client and Oracle, and that's supported by both intelligent and legacy policies. There's also the possibility to use Replication Director to support protection of Oracle policies on supported storage, supported NAS devices in the case of Replication Director, and that can also be done using OIPs or legacy policies. If you're sending Oracle backups to deduplicating disk pools, here's some best practices to consider. One thing to consider is the use of proxy copy backups. Proxy copies mean that instead of directly streaming the data from Oracle to NetBackup, Oracle RMAN specifies a set of objects, such as data files, for NetBackup to protect, and then the standard NetBackup client process, PPPICAR, comes along and backs up those data files. This is a procedure which is much more similar to standard file system backups. It is consistent across backups, and it tends to produce the best deduplication rates, and also doesn't generate an excessive number of jobs. Now, if you're going to go ahead with stream-based backups, the issue that you can run into is when you're backing up multiple data files, RMAN likes to multiplex the data on the backside in order to improve performance. It will read data from multiple open data files and combine it together into a single stream of output, and it will do this in any manner which optimizes throughput. RMAN is really only interested in performance, and this multiplexing, this combining of data, very well may happen differently in different backups, which means that the data that NetBackup receives is arranged differently in different backups, and that is a big impediment to good dedupe rates. The more of this that goes on, the worse your dedupe rates get. And so we could tell RMAN, using the files per set parameter, to only include one data file per backup set. That'll get me my good dedupe rates back. The only thing there is it means that a large number of backup jobs will be created. And also other enhancements to consider: disable Oracle compression and encryption during the backup. Remember, we never want to encrypt data before deduplication. Let the dedupe engine handle that. When we talk about Oracle Intelligent Policies, now because OIPs know that proxy copies get better deduped rate, by default, OIPs will automatically attempt to perform a proxy copy if deduplicated storage is selected and the database is not on ASM storage. Now, optionally, if I wanted to do a streaming backup instead, I could set files per set equal to 1 in the Oracle tab of the policy. This is the Oracle Database Disaster Recovery Considerations topic. There are 2 steps to recovering a relational database like Oracle. There's the restore, and then there's the recovery. The database restore is the replacement of lost or damaged files with backup copies. And this is basically like any other restore operation in NetBackup, where you're taking data files that you have backed up and you're placing them back on the client system. Following the restore, recovery is required to bring the database to a consistent state. And what happens during recovery is we do a roll forward of the redo logs to bring the database back to the state it was in prior to the damage. Specifically, what needs to happen during a recovery is the database needs to be returned to a consistent state. And so the database will roll forward and reapply transactions in the redo logs, and if it hits upon a bunch of incomplete transactions, it may actually roll back a little bit. Again, the important goal at the end of recovery is consistency. So here's a high-level overview. Step 1, preparing the database. Step 2, restoring the data. And Step 3, recovering the database. Note that the restore and the recovery are both handled by RMAN. So here's our steps for preparing the database. First off, when you first notice a crash, back up the database and the logs immediately. Now, this may seem a little funny, if I've noticed a crash, isn't it too late to do the backup? Well, it's still important to protect anything that you can, because the process of restore and recovery of a database will occasionally make things worse than they were before. So at least by capturing what I currently have, if I have anything, I have at least a known point to which I can fall back if things really go sour during the recovery process. Next, I'm going to go through and determine which files are damaged and decide whether it's going to be possible to restore to the original location or if a restore to an alternate location is required. Now, if the database was running in archive log mode and I was doing regular backups of those archived redo logs, then complete recovery up to the point of failure is possible. If the database was running in no archive log mode, then recovery of the entire database is possible only up to the point of the last cold backup. It's basically a point-in-time recovery. RMAN controls the restore process, and it will intelligently decide which data is needed for the restore based upon the options and configurations of the recovery script that's being run. RMAN will intelligently select the fewest number of backup pieces necessary to do the restore. And so full backups or level 0 backups will be recovered first, and then incremental backups will be applied, and then finally log files will be restored. This restore process will overwrite any existing data. Once the necessary files have been restored, recovery takes place. So RMAN applies incremental backups first, and then it does a roll forward on the archived redo logs that have been taken since the last incremental backup, and if necessary, it will do a minor rollback to roll back uncommitted changes. Again, the point of recovery is returning the database to a consistent state. RMAN uses the recovery catalogs to determine the best available backup sets. The RMAN restore command restores files to their original location from backups, overwriting existing copies. The recover command applies incremental backups, archived redo log, and any available online redo logs that happen to be on the server to bring the database to a consistent state. Here's an example of the RMAN commands used in restore and recovery. The database is first shut down and then started again in the mount mode, which means that the database is online but files are not open. Next, the channel is opened to the SPT, the third-party media manager, i.e. NetBackup. The data files are restored, and then recovery takes place. Incremental backups, archived redo logs, and any available online redo logs are applied, after which the status of the database is changed to open. Here's an example of the RMAN commands where the database was in no archive log mode and we were not doing regular backups of the online redo logs. And you'll notice it's pretty similar to the previous example, the only difference being that after any available data has been restored, the recovery uses the no redo switch. We're not going to be applying redo logs because we don't have any. Here's an example of a more granular restore, where we have a database that was running in archive log mode and there's a single table space that's corrupt. And so we want to recover this one table space, TS1. Note that the Oracle database remains open during recovery. We open a channel to NetBackup, restore the required table space, and then do recovery on that table space and bring it online. This slide shows the output from an Oracle RMAN script that was designed to restore and recover an Oracle database. The script is run on the Oracle host where the instance to be restored resides. So on the left here we see the output seen from the Oracle host when the script runs. The right part shows the details from the activity monitor in NetBackup. The first section shows the restore part of the operation where data is put back on the host. The second section shows the recovery, where archive logs are rolled forward and the database is returned to a consistent state. Another option for recovery, rather than using RMAN scripts, is guided recovery, which was introduced in NetBackup 7. Guided application recovery, or GAR for short, is used to clone Oracle databases, and you access it from OpCenter. The wizard in OpCenter allows you to select a particular control file backup and then based on that control file clone an existing Oracle database that has been backed up and restore it either to the original host or to an alternate destination. And all of the steps that are involved in the recovery are done graphically from the wizard. You don't need to know a lot of RMAN syntax to do it. And the wizard is going to provide an option to do a pre-check to validate the decisions that you've made to make sure that they're going to work before you kick off the recovery. From OpCenter, I go to Manage and then Restore. I have a choice there between file system backups or cloning Oracle databases. I select Clone Oracle Databases, and then I use the Oracle Cloning Wizard to go through and select my options, such as which database is being recovered, which version of it is being recovered, because I might have a long backup history, where it's being restored to, and will there be any options used as part of the recovery. And then restore jobs will be kicked off in the activity monitor, where I can monitor them to make sure they complete successfully. Here are some troubleshooting suggestions. Firstly, to verify that scheduled and user-directed file system backups work for the client. If those seem to work okay, then let's try to verify RMAN syntax. Try using RMAN scripts directly instead of using intelligent policies, and try to have RMAN write directly to disk instead of to NetBackup. And that can kind of try to isolate whether RMAN itself is the problem or whether NetBackup is the problem. There are detailed logs that can be created on the NetBackup side that can be useful for troubleshooting. I also should go through on a Unix or Linux system and make sure that NetBackup is properly linked to Oracle. Remember that this needs to be done when I first set up NetBackup to Oracle, and it would also need to be done anytime I upgrade my Oracle version, which again sometimes I forget to do. And so I can perform an interactive RMAN backup to tape from the command line to test this and see if the DB client log file exists. If this log is created, then the NetBackup and Oracle are linked correctly. If this log does not exist, there's a linking problem. In this lesson, you learn to identify the files that comprise an Oracle database and define common Oracle terms. You learned about the function of the Oracle Recovery Manager. You learned how to configure NetBackup to backup and restore Oracle databases and how to monitor NetBackup for Oracle backup jobs. And you learned to perform basic NetBackup for Oracle troubleshooting and to use GAR to monitor and manage NetBackup for Oracle cloning. This concludes Lesson 5.